Let me briefly introduce you to the two radio modules that we will be using in our experiments here. On the left here is the transmitter module, and on the right here is the receiver module. These two are based on the 433 megahertz band with the wavelength approximately being 70 centimeters. The transmitter module has 4 pins, two for the power supply, the ground and the 5 volts. And then one of the pins that is here, you can provide the data input by setting it to 0 or 5 volts. The last pin enable, this is something that we are not going to use in our application. The receiver module has 4 pins again, so ground and 5 volt on the opposite sides, and then the middle 2 pins, which are anyway tied internally, both provide the data output. So that's again in levels 0 and 5 volt. So what happens is when on the transmitter module you set the data pin high or low, this is going to cause the module to emit 433 megahertz. So when the data pin is set high, the transmitter module oscillates and sends out 433 megahertz. And when the pin is low, there is no wave sent out. And this form of modulation is an amplitude modulation, and more specifically, it is called amplitude shift keying. In fact, even more specifically, this form of keying is called on-off keying, because you either send the carrier wave or you send nothing. And the waves reach the receive antenna on this side, and there is electronics here which amplifies the signal, filters it out, and then on the data pin here provides a corresponding signal out. So if everything works fine, what you pulse out here on this data pin should appear transparently on the data pin here. So this is the idea of these two modules here. Now, something that might be relevant to know is that the receiver module has something called as the automatic gain control. And what this does is the electronics on this, it senses the signal strength that is coming in at the antenna and automatically adjusts its amplification so that the output remains quite stable. And this is relevant for our experiments because you will realize that if there is no transmitter in the picture, your receive pin would still be pulsing out some signals, and this is because you do have several modules in the environment and some weak signals may reach this module, which the automatic gain control now amplifies and uses it. But on the other hand, if you have a strong transmitter in the neighborhood, then the automatic gain control is going to latch on to this signal strength, and then you are only going to get data from here to here. So this is a factor that you might be puzzled when you see unwanted signals coming on the receiver. I have here an Arduino Nano board, which is actually a microcontroller, an Atmel microcontroller, the chip that you see here. I've placed this on a breadboard. Remember on a breadboard that the central ridge that breaks the connection between these vertical points and these vertical points. So make sure that you put your Arduino Nano across the bridge and you place it like this. Then you can put the transmitter module here on any of these sets of the vertical pins here and start wiring them up. I will show you the wiring diagram. So in this case, I have the positive 5 volt, the negative ground, and the data pin connected here. So I have chosen to connect the data pin to D12 here. That's the last pin here. The ground and the 5 volt are labeled on the board here. So although it's not quite visible, but you can figure it out on this. And in a similar manner, you also can wire the receiver board Once again, you place the Arduino Nano across the bridge on the breadboard and wire the plus and minus 5 volt. Then you get the data pin, put it here. So I have chosen to put the data pin on D11 here. So in this way, you will have a transmitter board and a receiver board. Here is the wiring diagram schematic. So you have the Arduino Nano here, and for the transmitter you need a data pin, and then the power supply, the positive 5 volt, and the ground here wired up. And similarly for the receiver, you have the ground and the 5 volt wired up here, and then the data receive pin connected to D11 on the Arduino board. Okay, now to test if our setup is working properly. Just to remind you, I have the transmitter board here and the receiver board here. To see if this works fine, I created a very simple program here. On the left side is for the transmitter. What the transmitter does is to send out pulses of 50 millisecond duration. So I hold the output pin high for 50 milliseconds and then hold it low for 50 milliseconds. To remind you, my output pin is connected on the GPIO identifier 12, the D12 pin. So this piece of program is going to forever try putting out pulses on the transmitter side. So if you remember, if this happens, then on the air we should have the 433.92 megahertz pulsating in this form, and this is going to come onto the receiver board. Good. Then on the receiver side, once again a simple program. I am using D11 as my receive pin, and I've set that up as the input here. In addition, I'm going to use the serial port. The Arduino boards can send out messages on the serial port, which is over the USB here. I will show you how this looks like. And so I set up the serial port at 115-200 baud. So that is the setup. And then in the loop of the microcontroller, I read the status of the RX pin and print it out, then wait for the 50 millisecond and again read it out. Hopefully, if this works fine, then my 50 millisecond pole would eventually be giving out ones and zeros in succession. Good. So to upload the program, what you need to do is to connect the Arduinos via USB to your laptop or PC. And then it should appear as COM ports. In my case, I have two of these boards connected. They came up as COM75 and COM78. If it is the first time you're doing this, then you would have to, after connecting one of the boards, you have to go here and say on this port you have an Arduino Nano connected. So this is a one-time activity that you need to do on the Arduino IDE. And once you do that, then you have the transmitter, which is here, COM75. The COM identifier may be different in your case. I'm quite sure it will be something different. And this is COM78. And COM78 in my case is not the transmitter but the receiver here. So be careful that you don't mix up the program and upload the wrong program to the wrong board. So, and once you're ready, you click on the upload button. This will upload the program to this microcontroller, and then upload button on the second IDE will upload it here. So we have the two programs here and here, so you don't see physically anything happening. So on the receiver side, what you could now do is to open the serial monitor here. So when you open up the serial monitor, So when you open up the serial monitor by clicking here, you see the data that is getting streamed over the USB port here, and you see a section of ones and zeros being printed out here. So in this loop, we are reading the state, printing it out, waiting, and doing it. So in this case, the stream of zeros and ones sent by the transmitter is being received successfully on the receiver board here.